Welcome. All right, what I want to do is I want to show you guys how to help you solve equations. And on this video, what I'm going to do is part one, which is going to be one-step equations. So this is going to be a very introductory part to solving equations. To get started, we want to first make sure that we understand what even an equation is really rooted around. And an equation is rooted around what we call the equal signs. And one thing, you need to think of equation. Well, that has the root of, EQUA, EQ, which is the same thing as like equal. And what we want to make sure when we're dealing with an equation is that one side of the equation sign has to be equal to the other side of the equation sign. So that's what we mean by equations. And what we have is one side is equal to the other side. And we represent that by these two little parallel lines here. Now, let's look at some basic examples. We could say that 4, we know, is equal to 4, right? However, you can say that 3 is not equal to -5. These numbers do not have the same value. These two numbers do have the same value. Now, the next thing that we're going to work on is finding a value that's going to make an equation true. So when we're talking about equations with variables, what we're going to want to do is we're going to want to find the value of a variable that makes it true. So let's look at the example 4 equals 4. We know that 4 is equal to 4, correct? Well, what if I said, let's say x? I don't know the value of x. X can represent any number that we want it to be. However, if I want to now say x is equal to 5, what is the only value for x that will be equal to 5 that's going to make that equation true? And obviously, the only answer is x has to equal 5. Because therefore, when x equals 5, I can now plug it in and say 5 is equal to 5. All right, so a couple things to make sure when you're looking at equals, when you're talking about equations. One side is equal to the other side. And anything that whenever you're finding the value for a variable, you're finding that variable that's going to make that equation true. Now, there's a process that we come upon when we're finding the value of x. And what that process is what we like to say isolating the variable. And what I mean by isolating a variable is getting our variable to have a coefficient of 1. I'm going to show you a couple step-by-step methods to find the value of our variable that's going to make our equation true. So, first of all, there's a couple things we need to know about equations, or some things that can make it work. One thing is, before I get to that process, let's take a look at a couple examples. Let's have 5 equals 5, 4 equals 4, 2 equals 2, and 3 equals 3. Now, there's a couple things I want you to understand, which we call equivalent equations. And what that means are also the properties of equality. And what that means is when you have an equation, these are all true equations, correct? Well, the special thing that helps us with equations, what we can do is, if I do the same thing to the left and right side, I'm still going to have equivalent equations. So what I mean by that, let's take the number 5. If I add a 1 to the left side, I have to add a 1 back over to the right side. And the reason why is that's going to give me an equivalent equation. If I didn't add a 1 to this side, I would have 6 equals 5, which we know is not true. And remember, we want our equations to be true. So therefore, if I'm going to add something on the left side, I have to make sure I add it to the right side. Equivalent equations. The same thing can be said with subtraction. How about I subtract a 1 on the left side and I subtract a 1 on the right side? That will also give me equivalent equations. 2 minus 1 is 1. 2 minus 1 is 1. Therefore, those again are equal. Now, that's for addition and subtraction. Multiplication and division works the exact same way. Let's say I divide by 2. I'll still get 2 is equal to 2, which is an equivalent equation. And multiplication. Multiply by 5. 15 equals 15. So these are what we call our properties of equality whatever you do to one side, you can do to the other side, and you will still have an equivalent equation, meaning your equation will still be equal on both sides. So therefore, we know a couple things we can do. If we have an equation, one side is equal to the other side, we can apply these properties of equality. This is what we call the addition property of equality. Whatever you do on one side, you have to do on the other side, but it will still result you in an equivalent equation. We can do the division property of equality. Dividing on the left side, you have to divide on the right side. Subtraction property of equality, and multiplication property of equality. Let's take a look now at a couple examples on how to solve these. And then what I'll do is give you some problems for you to solve as some examples. So what we have here is we say a number. We don't know the value of x, right? We don't know the value of x. X can represent any number. But we want it to represent the only number. We want it to represent one single number that's going to make this equation true. So you could kind of say these out loud. One-step equations are kind of easy to get around because a lot of times you're going to say them out loud and say, well, what number plus 5 equals 10? And you say, oh, the answer is easy. It's 5, right? Well, we kind of want to get out of that mindset. And the reason why is because we're going to start going into other videos and other steps that it's going to involve a lot of different processes that it's going to become very difficult for you to always start trying to think in your head, you know, oh, just undoing the operations. What we want to do is we want to go with a process. And that process, what I was talking about, was getting our coefficient to always have a coefficient of 1. Or a lot of times, sometimes what we also call is calling the inverse operations. Well, here I have a coefficient of 1, so that's very good. However, I have a number that's added to 5. I want to isolate my variable, meaning I want to get my variable all by itself. I want my final answer to be x equals. So what I have on this left side is I have a plus 5. And what I want to do is I either want to use the inverse operation, which is like the opposite of adding, which would be subtraction, to get rid of that 5. So what I want to do is if I subtract a 5, and remember, you have to use subtraction property of equality, doing whatever's on the left side and what's on the right side. Now it's okay, since I did it on both sides, I will have equivalent equations. Well, what happens is now I'm isolating this variable to get my x by itself. So 5 plus 5 minus 5 is going to give me 0. X plus 0 is equal to 10 minus 5, which is 5. Now obviously, x plus 0 is going to equal x. Therefore, my value is x equals 5. So on this equation, what I have is, my answer is 5. 5 plus 5 is the only answer, plus 5, that's going to equal 10. And it's pretty simple, but we can always check your answer by plugging it back into your equation to see if it works. 5 plus 5 does indeed equal 10. Now let's work on x minus 2. For this equation, what I'm going to do is now to isolate this variable, I have a coefficient of 1, which is good. Now I need again to get my variable all by itself. So again, I want to get to x equals all by itself. So what I have is now I'm subtracting a 2 from my variable. So to undo subtraction, to get that variable all by itself, to undo subtraction, I'm going to have to add. And again, what I'm going to have to add is since I'm subtracting 2 from my variable, I'm now going to want to add 2 to my variable. And again, I have to make sure I do that on both sides of the equal sign. Now when doing that, when I'm adding it on both sides of the equal sign, what I've now obtained is x plus 0 equals 5. And then obviously x plus 0 is x and equals 5. So again, I actually have the exact same answer for this one. And what it says is x is equal to 5. So now let's go and check our work, see if that works. If I plug in a 5 in for x, minus 2 equals 3. So 5 minus 2 is obviously 3 equals 3. Now, that is a true statement, so therefore our two sides are equal to each other. And again, you could also say it in your head, just double check it. What number minus 2 equals 3? Well, you think in your head, yes, that's going to equal 5. So that works. One-step equations are pretty easy to do. Here, this is probably the hardest problem that I have for a lot of my students. And the reason why is they look at this and they say, oh man, now I don't know what's happening. Well, if you look at this problem, notice that you have an x being divided by a 4. All right? And when you have a number being divided by a 4, the opposite of division is to multiply. So if I'm divided by 4, the opposite of that is to multiply by a 4. And remember, you want to do your inverse operation to undo it. So therefore, what I have is a 4 divided by 4 times x equals 1 times 4, which is 4. Well, 4 divided by 4 is equal to 1. 1 times x equals 4. 1 times x is obviously going to equal x. Therefore, my final answer is x equals 4. When I plug that back in, 4 divided by 4 equals 1. And does 4 divided by 4 equal 1? Obviously, 4 divided by 4 is 1. So therefore, it checks out. For my last equation, I notice that my variable has a coefficient of -7. And I want to get that coefficient to be 1. So what I'm going to have to do to undo that coefficient of -7, which happened is that's multiplying, right? Your coefficient is what's multiplying by your number. For -7, that's multiplying by my number. So what I'm going to want to do to undo -7 times that number, or -7 times x, I'm going to want to divide by a -7. And again, make sure that you're using division property of equality. You divide your -7 on both sides. Just like over here, I did multiplication of equality. I multiplied on both sides. And that's okay because what you have is equivalent fractions. These will cancel out. So now I have a -7 over -7x equals -14 divided by -7 is a +2. This, again, will cancel out to become 1. And therefore, x equals 2. I plug my problem back in. Does -7 times 2 give me a -14? And the answer is true. So therefore, that's 4 examples for you to go and check out. What I'd like to do now is give you 8 examples to try on your own, see how you do, and then I'll come back and check your work. All right, so here's the problems that I'd like you guys to do. If you could just take the time and write them down, please. I'd like you guys to work on these problems on your own, and then what I'll do is I'll go and give you guys some tips after you've written them down. Okay, now what's going to come into is tip time. So what I'd like to do is kind of tell you some tips. If you haven't already listened to the introduction, you still don't understand what's going on, try going through that introduction again and really listening to it so you can see exactly what you want to do. So for these first problems, just to kind of work on these first 4, I'm going to kind of give you some tips to think about to look at solving these. And I really want you to avoid doing them in your head. I'm pretty sure a lot of you, when doing these, you're going to be quick tempted to say, oh, what is the answer in my head? I really want you to work on the process of using equivalent equations and our properties of equality. So remember here we have a number subtracted by 9 equals 18. What you're going to want to do is look at how can I undo subtraction? What is the opposite of subtraction that I can do for this variable? That's kind of like my tips number 1. So think of what is undoing subtraction. Here, to get my variable itself, I'm adding my variable to 3. So my variable is x, I'm adding 3 to it. So to undo addition, I'm going to have to do what? Here, I have multiplication, and my coefficient of my variable is greater than 1. So I need to get my coefficient to be 1. Right now it's at 2. So to undo multiplication of 2, I'm going to have to do what? And here, this is a fraction. And remember, a fraction is dealing with division. So what I'm going to want to do is undo division by 4. So to undo division, I'm going to have to do what? And then also, guys, make sure that whatever you do on one side, if I undo division, I have to make sure I undo division on this side. If I'm going to undo multiplication, I'm going to have to undo multiplication on both sides. And remember, as long as you do it on both sides, you will have equivalent equations. Now let's look at the tips over here. It's okay with this one. This one's a difficult one. But what I'd want to do to solve for this equation, a quick little tip I would say, is remember that's just a -1. So I would rewrite this problem as maybe a -1 times b equals 8. That might help you out to solve that problem. Here, I have a double negative. I know I didn't know, well, what happens when you have negatives next to each other? Well, remember, a negative minus another negative is going to actually cancel each other out to give you a positive. So this problem can actually be rewritten as x plus 2 equals 8. All right. A tip down for this one is here, so far we've always been solving for variables on the left side. And that's pretty standard. We like to solve for variables on the left side. However, sometimes you will incur a variable on the right side. So still do the problem in the exact same way. However, if you'd like a little tip, we can make this easier by rewriting our equation with p plus 3 equals 10. And then the last one is here what I did is I rewrote a division as a multiplication of a fraction. So it's a lot of the same thing. What's really happening is the exact same process is going on. And think about it this way. What is 1/2 of 10? Well, 1/2 is 10, we know is the answer is 5. Well, the same thing is what is 10 divided by 2? Well, we know the answer is also 5. So you can either write it as a denominator, dividing your number, or you can also just take it out and put it as a fraction, multiply your number. Either way, it's still doing the same operation. So just look at this and say, well, what operation do I want to do to undo either multiplication of 1/5 or dividing by 5? All right, so that was your tips. Now what I'd like to do is show you how to actually solve each equation. So what I'm going to do for the first ones is, remember, we have our variable, it's by itself, but it's subtracting a 9. So to undo subtraction, I'm going to want to add. And remember, you're going to have to add on both sides by the addition property of equality. And when you add on both sides, you will still produce equivalent equations, meaning my equations will still be equal to each other. Therefore, I have v equals 27. Remember, a -9 and a 9, what we sometimes say is cancel out or gives us a 0. Over here, I have x plus 3 equals 5. My variable is being added by 3, so to undo addition, I'm going to want to subtract the 3. Therefore, I have x equals positive 2. Remember, these two, what we say, are cancel out. Positive 3 minus 3 gives us 0. Here, I have my variable is being multiplied by 2, so to undo multiplication, I'm going to want to divide by 2 on both sides. Therefore, I have 2 divided by 2, what we say cancels out, because what it does is it gives us 1. And 1 times y is going to give us y. So therefore, y equals 10 divided by 2, which equals 5. For my final answer, or my final problem up here, I have p divided by 4 equals 1. So to undo division by 4, I'm going to want to multiply by 4 on both sides. So when I multiply by 4 on both sides, this cancels out to give me 4 divided by 4, which is 1. 1 times p is p. P equals 1 times 4, which is 4. Just remember that whatever you do on one side, you have to do on the other side. And also, you always want to do your inverse operations. If I'm dividing, I multiply, and I multiply on both sides. Multiplication property of equality. Here, I'm multiplying, so I want to divide on both sides. Adding, subtract on both sides. Subtraction, add on both sides. Let's check our answer. Does 27 minus 9 give me 18? Yes. Does 2 plus 3 give me 5? Yes. Does 5 times 2 give me 10? Yes. And does 4 divided by 4 give me 1? Yes. So to solve for this problem, our most common case that we like to do is divide by -1. Therefore, v equals a -8. Over here, I said your tip was to change this to an addition problem. X plus 2 equals 8. Since I'm adding a 2, I'm going to want to subtract. Therefore, x equals 6. Over here, I said to rewrite the equation. P plus 3 equals 10. To undo addition, just like this one, I can subtract. And for here, I said you could also rewrite this like a division problem. W over 5 equals 7. Opposite of division is multiplication. So W equals 35. And that is how you solve one-step equations. Thank you for watching.